If you look around our universe, you can see that it is permeated with many shining galactic threads, and STN. Between them stretch vast areas of deep emptiness hundreds of millions of light-years in diameter, which are called voids. These enormous cosmic failures reach such incredible sizes that the largest galaxies seem like grains of sand against their background, and some stars burn to the ground faster than a photon flies from one edge of the cosmic abyss to the other. Even the omnipresent echo of the Big Bang fades away in their endless depths, which keep many secrets and mysteries. This means that the time has come to go to the very heart of the great cosmic void. From the point of view of the scale of space, our planet is just a small rocky fragment flying at enormous speed through the endless void. For billions of years, it circles in its orbit, maintaining a distance of about 150 million kilometers from the Sun, but the true size of our system is much larger. According to modern ideas, its outer boundary, which is considered the far edge of the hypothetical Oort cloud, lies at a distance of about 100,000 astronomical units. Beyond this boundary begins the endless abyss of interstellar vacuum. Space is so rarefied that on average there is only one single hydrogen atom per cubic centimeter. The distance between the nearest stars in our part of the galaxy is on the order of several light-years. And a photon leaving the Sun can reach Proxima Centauri without ever colliding with a particle of matter. This endless emptiness is an all-pervasive and integral part of the deep structure of the cosmos. It permeates the entire Milky Way, separating planets, black holes, and white dwarfs, superdense pulsars, and diffuse nebulae with an insurmountable abyss. If you move beyond the galaxy, you can see that it is surrounded by an even deeper vacuum. For example, between us the Andromeda Galaxy lies 2.5 million light-years, beyond rarefied space. This distance is so huge that 25 galaxies similar to ours could fit in it, but it is filled only by the deep vacuum of space. And this is only a small part of the great cosmic abyss. All the penetrating invisible threads of gravity bind together the Milky Way, the Andromeda Nebula and the Triangle Galaxy, as well as about 100 of their satellites. This structure is called the local group, and is a large accumulation of cosmic matter, with a diameter of about 10 million light-years. In turn, the local group is part of an even larger formation, a relatively small galactic thread by the standards of the universe, called the local sheet. This simplified structure consists of several hundred galaxies, has a diameter of about 46 million light-years, and a thickness of about 5 million light-years. Leaf is part of an even larger association called the Virgo supercluster. However, very close to the local leaf, outer space suddenly changes its appearance. Here, the usual colors of the universe are disrupted by a gigantic black hole, known as the local void or local void. In fact, the local leaf is one of its walls. Other conventional boundaries are the Perseus fish supercluster and the Indian peacock supercluster. At the same time, the void is divided into conventional parts by several discharged galactic threads, and wide passages connected into a single network with the adjacent voids, the Sculptor and the Hercules. Due to the cosmological expansion of the universe and the gravitational influence of surrounding matter, the volume of the local void is slowly increasing. Currently, its diameter is about 150 million light-years, and the distance to the center is at least 70 million light-years. Meanwhile, the nearest edge of this cosmic void is located very close to the Earth, at a distance of about 3.2 million light-years. Thanks to this proximity, the local void occupies a significant part of the night sky of our planet, about 40%. The main plane of the Milky Way, containing many bright stars and large nebulae, obscures the central part of this region from us, but its edges remain accessible to observation. In 1854, a dwarf spiral galaxy called NGC 6503 was discovered slightly north of the constellation Hercules. Later, with the development of observational technology, it became known that it is located in the middle of a local void, and its distinctive feature is the incredible multicolored appearance. The galaxy's spiral arms are riddled with bright red blobs of heated hydrogen, and brilliant blue nebulae are the birthplaces of stars. The center is darkened by clouds of cool gas and dust, which have a noble brown color. The diameter of NGC 6503 is about 30,000 light-years, and the distance from Earth reaches 17 million light-years. Thanks to the attraction of the Virgo supercluster, this galaxy is approaching us at a speed of about 43 kilometers per second. It is believed that a gradual approach to the local sheet will ultimately saturate its space with interstellar hydrogen, which will provoke growth and star formation. According to calculations, in a few billion years the number of young stars may double from the current number, and the small galaxy will shine with renewed vigor. The movement of NGC 6503 is a clear demonstration of how the voids most likely formed. It is believed that the main large-scale structures of the universe were laid down in the first minutes of its existence, during a time of chaotic mixing of matter and energy. Cosmic cataclysms of incredible power shook the young universe, forming local compaction and voids. Subsequently, the clots of matter became protocol optical clouds, and the space of reduced density became voids. Over time, the pervasive influence of gravity intensified this contrast, walling in stars and cosmic gases into relatively dense clusters, making void space even more tenuous. Observations show that the vast majority of galaxies formed between 10 and 13 billion years ago. In addition, no significant differences were observed between the ages of galaxies located in voids and those that form global filaments. This fact also confirms the modern theory of the formation of large-scale structures of the universe. Meanwhile, knowing about the cosmological expansion of space, we can assume that over time the local void will become larger and more rarefied, and the Virgo supercluster will gradually disintegrate into several independent groups. Currently, it is a union of approximately 30,000 galaxies, concentrated in a region of space with a diameter of about 200 million light-years. At the same time, the total mass of the cluster is about 1.5 solar quadrillion, which is similar to about 1,000 galaxies such as the Milky Way. The Virgo supercluster is partially in contact with two other galactic superclusters, Centaurus and Pavonus Indianus. At the same time, another side of it borders on a vast area practically devoid of matter. It's called the Taurus void, and is one of the largest known cosmic voids. The exploration of this area of outer space faces great difficulties. The thing is that most of the void lies in the so-called region of avoidance, in a sector closed from us by the plane of the Milky Way. The bright stars of our galaxy outshine fainter, more distant sources, and interstellar matter absorbs and scatters their light. However, thanks to research in the infrared range, we still have some idea of the structure of this void. The diameter of this enormous void is about 200 million light-years, and the distance to the center is approximately 150 million light-years. When observing the void, one immediately notices a surprisingly clear boundary between relatively empty space and a bright cluster of galaxies located much further away. It is called the Perseus-Pisces supercluster, and is one of the largest in this part of the universe. Such a sharp transition is typical for dust clouds, but infrared studies do not confirm their presence. In all likelihood, their clear boundary between the void and the supercluster is due to gravitational reasons, but we have yet to figure out the exact mechanisms at work. Meanwhile, it is assumed that the Taurus void, like most other cosmic voids, is not as empty as one might imagine. The distortion of light passing through it suggests that this area may hide giant clouds of gas and dust in its depths. Cradles of future galaxies. According to other hypotheses, huge masses of dark matter may be hiding inside the void, the most mysterious substances in the universe, properties that are still not fully understood. The most daring ideas place clumps of antimatter or even more exotic matter with negative mass in the center of cosmic voids. However, despite their boldness, these hypotheses lie outside the boundaries of generally accepted scientific concepts, which makes them quite difficult to test experimentally. Currently, only two separate galaxies have been discovered lost in the space of the giant void. One of them, UGC 2627, has a spiral structure and is similar to the Milky Way. The second is known as UGC 2629 and belongs to elliptical dwarf galaxies. Both objects are located almost in the very heart of the void, at a distance of about 185 million light-years from us, but the distance between them is small, lying within several 100,000 light-years. There may be other solitary galaxies hiding in empty space, but the disk of the Milky Way prevents them from being seen. Meanwhile, the Virgo supercluster, along with 4 other superclusters, forms a giant galactic filament called Laniakea. It contains more than 100,000 galaxies and stretches over 500 million light-years in space. Its gravitational center is the Great Attractor, a mysterious supercluster of galaxies located 250 million light-years from Earth. In turn, Laniakea is part of a vast galactic flow, and moving away even further, you can see that most of it is surrounded by a black abyss of unprecedented proportions. The light of distant galaxies drowns in its emptiness, and even the mysterious and elusive neutrons will take billions of years to cross this cosmic abyss. And it's hard to believe that despite all the development of observational technology, such a gigantic void was noticed only 10 years ago. 2013, University of Wisconsin-Madison. A team of astronomers, led by Professor Emmy Berger, is determining the distance of galaxies. During the research, an unexpected and stunning fact is discovered. It turned out that Laniakea, as well as most of the superclusters adjacent to it, are surrounded by a cosmic void of unprecedented proportions. After carrying out calculations, scientists discovered that its diameter exceeds the size of any previously known void. The scale of the discovered void was so enormous that it called into question several fundamental cosmological principles. Obviously, the universe turned out to be much more complex than we imagined. The research of Emmy Berger, Rina Keenan, and Linux Cowie has led to what appears to be one of the greatest astronomical discoveries of recent years. Their work showed that our galaxy, along with its surroundings, is located in the middle of the largest supervoid known to science. It was named KBC, after the first letters of the names of the discoverers. Observations show that the shape of the giant void is close to spherical, and its diameter may exceed 2 billion light-years. According to calculations, the Milky Way is located several 100 million light-years from the conventional center of the Great Cosmic Abyss, and at approximately the same distance from its edge. The discovery of a giant bubble of emptiness surrounding Laniakea helps explain a paradox that has puzzled scientists for many years. The fact is that all galaxies in the universe are gradually flying apart due to cosmological expansion. Measuring the speed of this movement allows us to calculate the so-called Abloh constant, a fundamental physical constant that characterizes the rate of expansion of space. However, if we take the galaxies closest to us to calculate the Abloh constant, it turns out that the rest of the universe is expanding too slowly. Conversely, if we take distant objects as a basis, then the surroundings of the Milky Way are moving faster than they should. The discovery of the void put everything in its place. The fact is that the galaxies inside it, including the Milky Way and its neighbors, constantly experience additional gravitational influence from objects outside the void. It creates additional force, which gradually stretches our cluster in different directions. What is also surprising is that the KBC void is so huge that it includes not only a supercluster of galaxies, but also other voids. For example, the local void, like a warrior, is an integral part of its structure. It turns out that compared to other voids, the KBS looks large, but not so empty. However, against the background of the observable part of the universe, the diameter, which, according to calculations, reaches 92 billion color years, even this is just a barely noticeable dark speck. If we look at the global map of the universe, we will see on it many dark spots that are close in scale to the KBS entrance. Most of them easily fit into the framework of modern physical theories. Others exhibit amazing and strange properties that are difficult to explain from a scientific point of view. and one of the most notable of such cosmic mysteries is the supervoid Eridana, also known as the relic cold spot. According to calculations, its diameter ranges from 500 million to 1 billion light-years, and the distance from the Milky Way ranges from 6 to 10 billion light-years. This means that this formation is one of the most extensive elements of the large-scale structure of the universe. The void is located in the southern hemisphere of the Earth's sky, and occupies an impressive area, several times larger than the full moon. However, it is impossible to see it with the naked eye. The relic spot is visible only with the help of special telescopes that study space in the microwave spectrum. Thanks to them, astronomers discovered that within the sunspot, the cosmic microwave background radiation of the universe is about 70 microkelvin cooler than the metagalaxy average. This deviation is almost 4 times greater than the strongest anomaly recorded previously. And its gigantic size makes it a truly mysterious object that requires comprehensive study. It is currently believed that the cosmic microwave background radiation, passing through hundreds of millions of light-years of deep vacuum, experiences gravitational influence from distant galactic superclusters. This causes the pervasive echoes of the Big Bang to lose energy, causing the CMB to appear cooler in images than its surroundings. However, this effect is not able to fully explain the excessive cooling of the cosmic microwave background radiation. According to calculations, the attraction of external galaxies can explain only a quarter of the observed deviation. It is assumed that the remaining 75% of the effect may be a consequence of the influence of hypothetical dark matter, or dark energy, concentrated in the depths of the void. However, it will be a long time before we truly uncover this cosmic secret. Observing space, we see hundreds of millions of galaxies scattered in space, each of which includes billions of various luminaries, millions of planets, and countless other celestial bodies. This infinite variety creates gigantic cosmic structures, spanning space in a radiant network. But all this is just shiny dust against the backdrop of the great emptiness that fills the universe. This emptiness is the true cosmos, mysterious and dangerous. Maybe in its depths are hidden the answers to the key mysteries of the universe, or maybe there is nothing there except endless darkness, barely comprehended by the mind. Whether we will one day learn its secrets, only time will tell.